video, we will talk about the linear least square regression that allows you to predict the data when there is an x and y variables of your data has a linear relationship to each other. So what you can do is you can just make your everything in your table form. You can say x and y, and then you can use your equation y is equal to a naught plus a1 times x to calculate this, where your a naught is nothing but your intercept, which is equal to y bar minus a1 x bar, and your a1 is equal to n sigma sum of all the x elements multiplication with y elements multiplication minus then multiplication of the sum of the x elements and sum of the y elements, and then you can divide that by n of sum of the squares of the x minus sum of the sum of the x's square, right? So here you can find your x, you can y, and we can find sum of x and sum of y down here, sum of xi, sum of yi here, and so those are those two terms in this one. The other term you're going to need is sum of multiple of the xy. This term can also be the same as this one. You just have to square it, and you have to find this term that is sum of the squares, right? So what you're going to do here is you are going to calculate xi, yi, and xi squares, right? So whatever data you get, and then here you find out the sum of the xi, yi's, and then sum of the xi squares, and you plug everything back into this, and in the a it's a y mean, and this is the x bar mean, so which is just dividing them by their number of data points, where n is the number of data points. But not all the systems, especially engineering system, have this kind of x and y having the linear relationship. So in this video, I'm specifically going to talk about something that has exponential model. How can we convert that to the linear model? So exponential model looks like something like y is equal to alpha e beta to the power x, and it can be used to define a lot of engineering systems. So how do we linearize it and then use the specific method to find out the values, right? So if I say this is my equation 1, what you can do is you can take natural log on both sides, and that will give you log y is equal to log alpha plus beta x, right? Now if you compare this to this equation 1, this equation 2, your y is basically equivalent to log y. Your a naught, that is your intercept, is equal to natural log alpha. Your x is equal to x, and your a1 is equal to beta. So whenever you're using this, if you have to use this system, you can predict using this log y, right? So how the log y will be predicted? You can use a naught, which will be the log of alpha, and then x as an x, and a1 will be beta. So which means the system input here was your x and y values. Now here the system system input is going to be log y and x, and system output or calculation output will be beta and log alpha. That can be converted back to alpha by taking exponent, and can be written in the form again y is equal to alpha e to the power beta x. And now you can use any x value to predict the y value without any problem. So how do we do that? So if you take a look at this example, right? So x values. So x values are 0 0.4, 0 0.8, 1.2, 1.6, 2, and 3. If you look from here, my x is fine as a system input, but for my y, which is here, is 800, 985, 1490, 9050, 2850, and 3600. So I cannot use this. So I'm gonna have to add another column that calculates the log y, and then instead of calculating the sum of the xi and yi's, my xi square is fine. I'm gonna have to find out the sum of the xi multiplied by the log yi, and then from there I can calculate my a1, which is going to be equal to beta, and then I can calculate my a naught, which is going to be my log n. So here is the thing, you can fill in all the values here and calculate these and perform this step and do this. I'm going to show you this using MATLAB. So let's start with the MATLAB. So with the MATLAB, let's say this is my command window, and I'm just going to maximize my command window, and I'm going to input my x values and y values from that problem, which is going to be, just give me 1 second here to get my values. So my x values are going to be equal to 0, 0.4, 0 0.8, 1.2, 1.6, 2, and 2.3. And my y values are going to be 800, 985, 1490, 1950, and 2850, and 3600, right? So, oops. So now, as I said, I have to calculate the log y. So I'm just gonna say log y is going to be log of y, right? So that goes as my input into my polyfit. So let's say I'm just saying a vector A is equal to polyfit x and log y, and I want just first order polynomial, right? So what MATLAB does is it starts with the highest power. So highest power is going to be a slope, and this is going to be your intercept, right? So this is your polyfit. Now, as I said, right now you have the values of the log y, and your this is the value of your beta, and this is the value of your log alpha, as we stated before. So what I'm going to do here is I'm going to use this to find out because this linear model should be giving me the log y values predicted, for which I need the x values predicted. So I'm just gonna say xp predicted, p for predicted, and I'm going to say these values in my x vector goes from 0.4 to 2.3. So I'm just gonna say lin space from 0 to 2.5, and I want, let's say, 10 values between those two, and that's it. Now if I have to use this to find out my y value, that is predicted log y value, that will be log y predicted should be equal to, given by our equation that we talked about, this should be just the value of your intercept, which is at the second position. So I'm just gonna say that a2 plus whatever the x you have chosen. So I have chosen my xp with the value at the first position, which is going to be my slope, and my predicted values are this. Now I can verify this by saying, if I want to plot my x comma log y, and I just make them color dots, color circles, and I can just say my x predicted and my log y predicted values should be plotted against each other. If you look at the plot, which is going to be right here, is the values that I plotted and I predicted. Is this the values from 6 to 8? So it's very similar to the one what happened here. Close figures, and I'm just going to plot again. I'm not sure why it is taking so much of time, but anyways, this should show up the same result that I had shown you before. So now what can I predict with this? The original function. And if I try to predict the original function, that is going to be my y predicted. So my y predicted should be equal to my alpha. So did I get my alpha? I did not get my alpha as my intercept. Rather, it was the log of that piece. So I'm just going to do exponent of my intercept, which is at the location 2 in the A matrix, and then I will multiply it with exponent of beta, which is at your first location, times with your xp predicted values, and that should give you the y predicted values. And now if you try to plot your x comma y and make them little r dots and say I want to predict xp and yp values, let me just refresh the MATLAB maybe. Yeah, so that is my x value and y values that I tried to predict for within that particular range, right? So I have these two plots that I tried to plot for between the logarithmic values of x and y. So that's how you implement these set of equations right here with regards to linearizing your exponential method. I will make another video for the power method after this.